Now, I've tried to get as clear a map as possible. And here on the screen, we have a map of South Africa, which shows us major routes and major towns in the country. Okay, I'm not going to scroll down all the way to the bottom because there's something I want to talk about at the top here. But you might see something like this in your exam or a test or an assessment. Okay, so this looks like it's a general route map for South Africa, showing all the national routes, all the national roads and highways across major cities in our country. Now, you know, for maps and plans, they're going to ask you a scale question. All right. Yes, there's some orientation. We'll talk more about that later on, but they're going to ask you a scale question. And we can see here on this map, they've given us a scale over there. All right. Who can tell me, how do we interpret this scale that they've given us? How does it even work? All right. If you've done maps and scales, maps and plans with scales on, you must have come across a scale like this. Who can tell me, how does this scale even work? In fact, let's start from the basics. What is the name of the scale? What type of scale is this? All right. Emmanuel, I see you have your hand up.
So the name of the scale is a bar scale, and how I was basically taught now is by either using a string if you have it in the exam, or you're going to use a ruler. Now you're going to measure how long the bar scale is, and then you're going to, like, between the places where you're trying to go. Take, for example, you want to go from Polokwane to Pretoria. The length of the bar scale on the ruler, perhaps in centimeters, you're going to put it there, and then you will be able to interpret it into kilometers and so forth.
Very good. Perfect. Thank you, Emmanuel. Excellent. All right. So just like Emmanuel said, you've got to use your ruler for this bar scale, or sometimes called a linear scale. You must use your ruler with this. Okay. So if I have a ruler and I'm going to draw a very basic ruler underneath it here. Okay. In fact, let's leave the arrows out and draw a perfectly straight line. You will put your ruler underneath this bar scale here. Okay. And usually if the examiner has done their job properly, the first centimeter mark on your bar scale, all right? So this little gap that I've drawn in over here, let's use a red pen rather. So this little gap on your ruler here should line up with the first major units on the bar scale, all right? So that 0 to 100 there should line up with 1 centimeter on your ruler. If it doesn't, it's not a train smash. Okay, but let's pretend that it does. So if we take this ruler here now, and I'm just going to pull it out. Okay, so here's my ruler. All right, and let's say this is 0 centimeters, and I'm going to draw a 1 here. All right, a 1 for 1 centimeter. I'll even write the units there. Okay, so you measure this on a ruler, that 1 centimeter matches the first 0 to 100 marker on your bar scale. What that means is this 1 centimeter represents this 0 to 100. Okay, and you'll see on the bar scale that there are units. So we can see here that they've got kilometers there. I've highlighted it in yellow. So if I write a little story about this, what I could say is 1 centimeter on my ruler represents, and instead of using the word represents, I'm going to use the colon, 100 kilometers. Okay, so sometimes they'll give you the scale written as a ratio like this. Sometimes they'll give you a bar scale. You've got to know how to use either one of them. All right, now you can take this scale here, which is a ratio scale or a number scale. All right, this is the number scale here. You can use either one of these and work out real world distances on the map. Just remember that the number on the left is ruler, let's use red. The number on the left is from your ruler, and the number on the right is real world. Okay, that's what we want. We want a ruler measurement that relates to a real world distance. Okay, so according to this bar scale, if we measure 1 centimeter on the bar, it represents 100 kilometers in the real world. And we can use that now when we work with this map. So we can measure, for example, I want to measure this little piece to this little piece here, all right, on the end one going towards Limpopo. So if I want to measure that piece there, and that works out to be exactly 1 centimeter, then that 1 centimeter on my ruler will represent 100 kilometers in the real world. So they asked me how far is it between those two red marks on the N1 going to Limpopo, or sorry, going to Polokwane. You could say those between those two marks, I measured 1 centimeter, so it must represent 100 kilometers in the real world. Okay, so that's how we can use the bar scale. All right, it's easy to use the bar scale. Like Emmanuel said, you take your ruler, you go there and you measure how many centimeters from 0 to 100, and then you go to your map and you can determine real world distances. Okay, so if they give you a map like this, more often than not, they're going to ask you a question relating to scale. So it's important to understand how the scale works. All right. Sometimes they give you a ratio. Sometimes they give you this number scale. Other times they'll give you a bar scale. All right. So we're using a bar scale in this example with this map over here. Okay. Let's have a look at the questions that they've given us. I'm going to leave my little ruler there, but let's have a look at the questions. All right. Here we go. Now, they often give you orientation questions. In other words, what I mean is you look at the map and orientate yourself around the map and ask basic questions on that. So here's the first question. But remember, in this revision course, we are doing exam type questions. This is why you see here question 2.1.4. This comes from an actual exam. All these questions come from exams. All right, so you're getting used to how they ask these exam questions. So question 2.1.4 says name 2 towns. You don't have to calculate. They just say name. Name 2 towns which they will pass when traveling from Port Elizabeth to Port Shepstone. Now we need to see Port Shepstone and Port Elizabeth. So you've got to orientate yourself around the map. Here's Port Shepstone. Here's Port Elizabeth. And obviously these people are going on a journey from Port Shepstone to Port Elizabeth. And obviously they're going to go on the N2 highway. All right. So if I draw a little here in blue, they're going to go along the N2 highway. So who can name 2 towns? You can put it in chat if you want. Who can name 2 towns that you will pass if you're going from Port Shepstone to Port Elizabeth? Anyone? You just look at the map and name 2 towns that you go through to get from Port Shepstone to Port Elizabeth. All right, Mthatha's 1. Very good. Well done, Viela. Mthatha's 1. East London is another one. And then right there at the bottom. Good. Yes, Pete. Well done. There's one more that you could name if you wanted to. You could also say Grahamstown. Yes, I'm sure. There we go. Thank you, Kamo. Well done, Pete. Good job. So Mthatha, East London, or Grahamstown, any one of those 3, you name 2 of them, and you get 2 marks. How easy is that? Fantastic. All right. Yes. So it's an easy 2 marks. Well done. Orabile. You've got 2 marks in the bag. Okay. Here's the next question. State the general direction. Now, these 2 words here, general direction of Lesotho from the Western Cape. Okay, we'll talk about Lesotho in the Western Cape now, but let's focus on the words general direction. Okay. Now, also with maps, you will often find that they will give you a compass. It's not often 4 lines like I've got here. Sometimes it's just 1 line with an arrow. Okay. So sometimes it's just an arrow going up like this. All right. So let me draw an example. So usually just have an arrow going up, which is got an N on for north. Okay. You've got to think of the full compass here. All right. So let's draw a little compass. And usually with maps, north is always pointing up. So I'm going to do north. Let's go down a bit here. South, west, and east. Okay, you've got to have an idea of these basic cardinal compass points. Okay. Hours to find a document data next day. I wrote the person. Cooking. Excellent. Good to hear that, Jabadi. All right. So these are the basic compass points: north, south, west, and east. So you need to have an idea of what these are and where they belong. All right. Not only that, because you also have to know these cardinal points over here. All right. The ones that are in between. Whoopsie. Let's not use an arrow. Okay, so we have to know these ones in between as well. Now, what I'm going to do is I'm going to focus on this first one over here. Who can tell me, you can put it in the chat if you want, who can tell me what direction is that one there between north and east? What do we call it? Between the N and the E, the north and the east, what do we call that direction there where there's a red question mark? All right, there we go. You guys are all very good. You guys know your cardinal points, all right, your compass points. So that's northeast, okay? And then the one on this side over here will be northwest. Notice how the north is always written first. Oop, we need an E there, sorry. So the north is always written first. Don't write it west, north, or east, north. Always put the north first. And then, good, you guys have got it. And then down at the bottom, these ones down here will be the combination of the south and the west. So southwest, and the one on the right is southeast. Again, always writing the south first. Okay. So those are all the points that you have to know. All right, good job. Yes. Well done, Jade. All right, so those are the points that you have to know. Now that we know this, let's take this imaginary compass, because this whole thing isn't given to you in the exam. Sometimes it's just north. You guys have to know or build your own, okay? So we're going to take this compass, and now we're going to go to our question. So what do we have to do? They say, state the direction, the general direction of Lesotho from the Western Cape. Now, where do I put my compass? The key is the word from. Okay, of Lesotho from the Western Cape. So your compass needs to go on the Western Cape. So when you see the word on, from, you're thinking of putting your compass on the Western Cape. Okay, so I need to take my compass now. You can draw an imaginary one in the exam on your map if you need to, or you can have just a general idea. So we put our compass here on the Western Cape. All right. In fact, the Western Cape is a whole province. Okay. The Western Cape is a whole province. So I'm going to just move it slightly inland. In fact, if I put it on the word there, you're probably safe. So it's on the Western Cape. All right. And we need to know Lesotho. Okay. Now I'm going to use a red line here. I'm going to use a thicker red line to draw a line from the Western Cape to Lesotho. All right. Now, this is the challenging part here, because if the examiner's done their job properly, this line should be very close to one of 8 of these cardinal points. All right. So according to my diagram here, which one is it closest to? Which one of these 8 cardinal points on my compass are we closest to? Neo. Check your screen there, Neo. You should see a little icon there to say unmute. You just click on that and you should be able to unmute. There we go. How are you? You okay then, yeah? Hi, Nia, you there? Nia, you there? Can you hear me? Nia, Betha, you there? All right, I think Neo can't hear me.
So he
right.
dropped his hand now again.
Okay, no problem. All right. Okay, so we got there, Sinako saying northeast. Yes, I would agree with you, Sinako. So I would say it's closest to this one here, the northeast. Okay, it will be obvious. You got to pick which one it's closest to, and then that's the one. All right. The most important part here is where you must put your compass. Okay, because some guys will put their compass on Lesotho. All right, which is going to cause problems. Because if I had my compass on Lesotho, hold on a second, guys, bear with me. I'm trying to move my big clumsy compass all the way up to Lesotho. Go up, come on, go compass, go. Off you go, nearly there, nearly there. Let's put it there. Bring it down a bit. There we go. All right, someone had their hand up there. I missed it. All right, so if I put my compass on Lesotho, then you would say that the red line is going southwest. All right, so you could either be saying northeast or southwest. Orabile, there we go. All right, Orabile, just check your screen there. You'll see a little icon to unmute. Orabile, you there?
Yes, sir.
How are you doing?
Yes, sir.
Are you well?
I'm good. And you, sir?
All right. I can barely hear you. You're breaking up a little bit. It might be your connection. I hope you can hear me. Yeah, you're breaking up there, Orabile. It might be your internet.
Yes, sir.
Yeah, it's we can
Yes,
barely.
sir. Can I ask on the yes, sir. Can you, sir?
All right, Orabile, we're barely hearing you. Can I ask you to type that question or your statement and put it into the chat if you can, because we can barely hear you.
Thanks, Orabile. I'll be looking out for your question in the chat. I'm muted you for now. Thank you.
Yeah, all right. It must be the internet connection. All right. Yeah, it does.
Okay, sir.
All right. So it depends on where you put your compass on which direction you're going to say. So like I said before, when you do this, please be careful about where you put your compass. All right. So if we go down to the question, you put your compass on where it says from. So if it says from Western Cape, that's where you put your compass, and then you won't go wrong. Okay. So they don't give you the whole compass. You got to draw a basic one. It's very easy to do. So you just go to the town where you want to go. Let's say from Port Elizabeth. You just put a little compass there. You draw your basic compass points, and then off you go. Okay. But it must be on the town you're going from. All right. Okay. Let's have a look at the next question. The next question is question 216. It says, write down one advantage of using a bar scale. One advantage of using a bar scale. No, Peter, it won't be right. It's got to be northeast. So if you write southwest, it means you are going from Lesotho to Western Cape. Okay, you're going the other way, in the other direction. You've got to put your compass on the Western Cape, draw a line to Lesotho, and then check on your compass which one you're closest to. All right. So if you wrote southwest, it means you've put your compass on the Lesotho, which is the other way around. Okay. All right. Who can tell me? You don't have to think too hard about this one. You don't have to go into a long story. When you see a bar scale, like Emmanuel was explaining, when you see a bar scale, what's one advantage of using it? Who can tell me what's an advantage of using a bar scale? So if I go up to the bar scale here, I get excited when I use the bar scale. You get a bar scale and a numerical scale. The size of the map. Okay, yeah. All right. Bar scales help with the size of the map. Okay. If you saw a ratio scale like this, would you prefer using a ratio scale, ladies and gentlemen, or would you prefer to use a bar scale? If you would prefer to use a bar scale, why? Yes. Okay, so it gives you the unit that you should use. That's a good one. All right, so if we look at this ratio or number scale here, there's no units to this. We have to do some calculations with a ratio scale. All right, the bar scale's got a measurement and it's got 100 kilometers for that measurement. So it's actually a lot easier. Oh, Emmanuel's saying he prefers the ratio one. I prefer the bar one. Just get my ruler out and I can measure off, but it's fine. Everyone has personal preferences. But a bar scale is easier. It's easier to use. Okay, this is why they put them on maps. You know, the proper maps, for example, if you're doing geography, they give you a ratio scale instead. They also give you a bar scale, but they also give you a ratio scale if you want to do calculations. But a bar scale is very easy to use, especially for simple maps. Yeah. And he's also a geography student. So, right. So a bar scale is very easy. Just take your ruler, you measure off, and then you go along. Okay. Ratio. Yes, ratio is more used in geography because you can do specific calculations and you can be a little bit more accurate. But in terms of a bar scale, I would say it's easy to use. So I think an answer for this question here, what's the advantage of using a bar scale? It's easier. Okay, write down one advantage of using a bar scale. It's easy to use, ease of use. All right. Right, easy to use. Okay. All right, now we're going to get into the meat of this question. 2.1.7. This is the one we came for. Well, I hope there's nothing more difficult than this. We'll see. It says here, the distance that John traveled to his uncle's place is measured as approximately 7 centimeters on the map. Someone must have measured that, right? They measured with the ruler and they measured 7 centimeters. Use the bar scale to determine the estimated distance in kilometers that John traveled. All right. Use the bar scale to estimate the distance in kilometers that John traveled. All right, let's read it again. The distance that John traveled to his uncle's place is measured as approximately 7 centimeters. Use the bar scale to determine the estimated distance in kilometers. All right, so we got to go from our ruler measured 7 centimeters to a real world kilometers. Okay, now I'm going to give you the scale to use, and then you're going to tell me what to do with it. So when we had our ruler and we measured here, 1 centimeter on our ruler gave us 100 kilometers on the bar scale. Okay, that's all I'm giving to you. You guys are going to do it and tell me how many kilometers John traveled according to this question. You must tell me how many kilometers they traveled according to this question. Okay, so that's the scale we're going to use. We took it from the bar scale where we measured 1 centimeter gives 100 kilometers. How far did John travel in the real world? You guys can do that one. Shouldn't take you long. You should have your pen and papers there. You can use my scale on the screen and calculate how far. Right, we're getting answers already. All right, we're getting the answers coming in now. Nice and easy. Wasn't too difficult. Good job. Okay, there we go. Good job. Okay, so I'm going to write the scale a little bit differently. I wrote it earlier on, but I'm going to rewrite it again. So I'm going to say that 1 centimeter is to 100 kilometers. That's what we get from our bar scale. I've just written it as a ratio. That's all. Okay, so then what if John did 7 centimeters? Okay, by your answers, there we go. There's Chade Booth with the calculation. All right, you got to multiply by 7. Why? Because how did we go from 1 centimeter to 7 centimeters? We times it by 7, didn't we? Well, you got to do the same on the other side of the ratio, like you guys are telling me. You got to multiply by 7. All right, to get this value over here. So you must say 100 kilometers times 7, nice and easy, and you guys will get 700 kilometers. Okay, very good. 1 centimeter is 100 kilometers. Then for 7 centimeters, you've got to times by 7. Good job. Don't forget your units as well. All right, that's for 4 marks, guys. That's 4 easy marks. You're hoping they give you one like that. Okay. Usually they ask you to measure yourself, but they gave us the ruler measurement in the question. Makes it nice and easy. All right. Is there nothing else here? Surely it's not that easy. Ah. Here we go. This is even meatier. All right. Question 217 was like chicken. 218 is like rump steak. Okay. So let's read 218. It says, John drives at an average speed of 110 kilometers per hour. Use the estimated distance calculated in 217 above to determine the time and round off to the nearest hour that it takes to travel from Port Elizabeth to Port Shepstone. So it's a speed, distance, time question. Okay. Now they give you the formula. All right. All we have to do is substitute into this formula to get our answer. All right. Now, this one's not going to be bad, guys, but I know that when we did these questions, we always had to be concerned about it. What was the concern? We even spoke about it last week. What do we have to be careful of? That's all. Just, you're not going to really hit an issue here because we're working out time and not speed. But what did we have to be careful of here? Who can remember when I spoke about it last week? You guys were there. What did we have to be careful of? I'll give you a clue. It had something to do with time. What did we have to be careful of? There's 2 formats that time comes in. You can tell me what they are. Time is presented in 2 different ways. You can remember. I spoke about this last week. Jenny's like, I know, but I don't know. Okay, yes, 12 hour and 24 hour. Good, you're right. Those are 2 ways we can write it. Yes, there's also another 2 ways that you can write time. There we go. All right, decimal hours. Okay, digital time. Yes, digital time. Yeah, Badi, that Petty is referring to digital time as well. Now, Bianca is saying, yes, Alzondi, good. That is true. 12 hour, 24 hour. Yes. But Bianca's mentioned decimal hours. Okay. So, for example, here, I'm going to write an example here. If I say 2 hours and 30 minutes, that's one format of that we can write time in, right? That's called hours and minutes. Okay, this is called hours and minutes. That's the hours and minute format. All right. Now, the other one is called decimal hours. Like Bianca said, decimal hours. So, Bianca, why don't you come and tell us, how can I write this hours and minutes in decimal hours? You there, Bianca?
Hi, sir.
Hi, how are you?
I'm good and you.
Good, thanks. How do I write 2 hours and 30 minutes as decimal hours?
You need to divide 30 minutes by 60 to get your hours.
Very good. So this little part here, the 30, Bianca's saying, so take that part there and divide it by 60. And Bianca, you know what we'll get?
I
What will we
haven't
get?
calculated.
You get the calculator to do that work for you. That's what it's there for. It must work for you.
It is 0.5 hours.
0.5 hours. All right, so 30 minutes is 0.5 hours. So what will this whole thing be? 2 hours and 30 minutes? How do we write that as decimal?
Uh-oh.
2,
Two
comma, 5.
0.5.
Okay, so this 0 that you've got over there, that'll
there.
be replaced by the hours. So these 2 hours will be here, and this 30 minutes will be the comma 5 over there. All right, so it's 2.5 hours. Okay, thank you, Bianca. So Bianca's suggestion that we must divide the minutes by 60 to convert it into decimal hours, that's the most important thing there. All right, thank you, Bianca. Good job. Okay, so do you get 2 different formats to write time in? Yes, you get the 12-hour format and the 24-hour format, but there's also 2 different ways here, hours and minutes and decimal hours. Okay, who can tell me which one of these does my speed, distance, and time formula give me? Which one does this formula want, and which one will it give you? Good question. Why do we only do it with the minutes? So, Yabadi, when we look at the hours and minutes format, this part here is behind the decimal here. So we only want, so this part here, the minutes is a portion of an hour. So we want to know that portion of an hour, how do we express that as a decimal? Okay, because the numbers on the left-hand side, yeah, the 2 over there and the 2 over there, those are whole hours. So we just want to know the portion of an hour, which is the minutes part. How much is that as a decimal? That's why we only take the minutes over there. Okay, who can tell me this speed, distance, and time equation? Which format does it use? Which format does it want? And which format will it give you? You put numbers in there. Which one of these formats, hours and minutes or decimal hours, will it give you? Which one does it want and which one does it give you? All right, you got to put the same format in that you're going to get out. But which one is it? Hours and minutes or decimal hours? I spoke about it last week. You can remember which one of these 2 that this formula likes. Oh, all right. I'll let you guys know. The format that this formula likes is decimal hours. All right, Bianca, decimal hours. This is the one that this formula wants. Please remember that. Okay, please remember that. All right. Someone's already done a calculation here, but please remember the speed, distance, time formula wants decimal hours to go in, and it'll give you decimal hours if you're asking for time to come out. Okay, all right, just remember that. So when the time comes out here, it's going to be in decimal hours. Okay, so now let's go look at the question. So this formula needs 2 things to give you time. It needs a distance and it needs a speed. All right, and if we go to our question, it tells us use the distance from question 217. Okay, and we've already calculated that it's 700 kilometers. All right, and then it tells us to use the speed of 100 kilometers per hour. So we've got our speed and we've got our distance. Those 2 things are going to go into this formula, and we're going to get a time out. Okay, so let's sub them in and see what happens. All right, so at the bottom here, I'm going to say T for time. I'm just going to use the capital letter T. I'm going to put in my distance, which is 700 kilometers at the top. And at the bottom, I've got my speed, which is 100 kilometers per hour. Checking, this is why you should always check that your units are the same in the formula. If you've got kilometers at the top and meters at the bottom, you're going to have to change something. You've got to have the same units there. Okay, so we got kilometers in both. That's fine. And then we go to our calculator and we're going to let the calculator do all the work for us. So we go to our calculator and say, hey, calculator, come. This is your job. So the distance of 700 at the top and this, oh, I made a mistake. It's not 100, is it? It's 110. So let's go back here. All right, let's check what it gets. Whoa, all right, a long decimal. 6,36363636. So 6,363636, blah, blah, blah. Time, this is in hours. Why do I say this is in hours and not minutes? Because I put in hours here, you're going to get hours out there. Okay. And this, like I said, this formula gives you decimal hours. Look, there they are. All right. They're the decimal hours. We just need to round this off like you guys have done already. So it's 6,36 hours. And this is decimal hours. Okay, so that's the answer for the question. All right, don't forget to round to the nearest hour. Ah, Pete, thank you. Okay, this is such a strange question. I don't know if you guys can notice it, but this one was for 3 marks. I feel like we're doing a lot more than question 217, which was for 4 marks. It's fine by me. I'll take the 3 marks wherever we can. All right, round off to the nearest hour. So Pete, what is it? Oh, I'm getting guys saying 7. All right, guys are saying go up to 7. All right, so when we round off to the nearest hour, we got to look at the hours. I've underlined it in red there. And then you look at what's next to it, which is a 3. Will that 3 change the 6? No, it won't. It won't. All right, so the 3 will not change that 6. If it was 5 and more, it would. Okay, so that 6 will not change. So this rounding should actually be closest to 6 hours. All right, only if it's 5 or over, Junior. Very good. All right, so we rounded off to the nearest hour. If they said round up, guys, if they say round up, if they take away this word off and write the word up, round up to the nearest hour, you always push it up, no matter what's behind the 6. Okay, but if they say round off, then you've got to look at the number that's behind the 6, and that will tell you where to go. Okay. You do get it sometimes, Junior. So they say round up, especially if, I'll give you an example of when. Let's say you are buying paint, okay? And there's a question in the exam and it says, determine the number of paint cans that you need to work to paint the wall. And they say 5 square meters, you need 1.5 liters of paint. But the paint cans only come in 2-liter cans. And you need exactly 1.5 liters, but the paint cans only come in 2 liters. In that situation, you have to round up. Don't round off, because if you go down to 1 paint can or 1 liter, you won't have enough. So sometimes you actually have to round up. So for example, if you need 1.2 liters of paint to do the job, but every can only comes in 2 liters, you can't round down. If they say round up to the nearest liter, you can't round down to 1 here because you won't have enough. So it depends on the situation. So in that situation there, you have to round up your paint because you need to have enough paint. All right, that's when you do round up. Also for people, so they say you're calculating and you need to know how many people can come to your wedding. You've got enough money to support or to cater for 36,2 people. You worked it out through some kind of question and you worked out you have enough for 36,2 people. Do you round off? That means you go down to 32. All right, you should always round up. Okay, so you can cater for an extra whole person. So there are situations where you round up, but when they say round off, we can go down. When they say round up, you have to go up. Okay, all right. Excellent. I think we get an idea of the speed, distance, time formula. Just remember time, always in decimal hours. All right, let's have a look. Guys, remember, if there's any questions, please raise your hand, stop me. Let's have a look at the next question. All right, here we go. Table and chair with some dimensions. What they're going to ask us here. Let's have a look. All right, so it's table and chairs with some dimensions in centimeters. What can they ask us here? All right. Yeah, rounding off so rounding off is common, okay? But in some situations you have to round up. All right, and sometimes, every now and again, the question will say round up to the nearest. Round up to the nearest person, round up to the nearest number of cans that you need. Okay, if you round down sometimes you won't have enough for the job. Okay. All right. So there's a table and chairs with dimensions. What are they asking us here? 311. Let's read this. If the length of the table on its scale drawing, because this is a scale drawing, is 8 centimeters, determine the scale of the scale drawing in the form 1 is to something. So what they're asking us here is to determine the scale. Determine the scale. This scale drawing doesn't have a scale. We have to create it. Okay. How are we going to create this? All right. Well, would anyone like to help me? Who would like to try? Who knows of how we could try to do this question? There's a scale drawing here of table and chairs. All right. They say that if the length of the table on the drawing is 8 centimeters, what do they mean? They mean that if you measure this here and you get a ruler measurement of 8 centimeters, but in the real world, it's 160 centimeters. They're saying, what is the scale of the drawing? Determine the scale of the drawing. 1,15. Oh, Jenny, I'm a bit lost. Not sure which one you 1,15 where what you're referring to. Is there a scale that I missed? No, there's no scale on this drawing. We got to determine the scale. 1,15 divided by 160. Divide the 160 by 8. All right, so Bianca's giving us an idea here. Let's have a look and see. All right, so just remember on the scale here, if you look at it, the left-hand side is the ruler. Remember that? And the right-hand side is real world. I'm just going to write the word real. Okay, so in our scale, the left-hand side's got to be the ruler measurement, and the right-hand side's got to be the real world. Remember, we've got to get this to 1 is to something. Okay, so on the left, we've got a ruler measurement of 8 centimeters. In the real world, it represents 160 centimeters. Now, this is a workable scale, but you never get given a scale like this. Your scale should have 1 is to something. So how can we change our 8 into 1? All right. Bianca has got it there. She's got it. She's on track there. I'm going to write it above, and I'm going to say here 1 is to. And what did we do to our 8 to get to the 1? We had to divide by 8, right? 8 divided by 8 is 1. So like Bianca says, divide the 160 by the same thing. Okay. So let's do that with a calculator. 160 divided by 8 is 20. All right. So the calculation you will do is you'll say 160 centimeters divided by 8 equals 20 centimeters. Okay. Then you've got to write out your scale. Okay. So once you've done that calculation, you've got to write it out in the form as 1 is to 20. Okay. Very good. Yes. What you do to one side, you got to do to the other side. So they want it in the form 1 is to. So we've written it there. 1 is to 20. So that's the scale that we could use for this scale drawing. We've got our own scale. We worked it out by ourselves. What's next? Use the scale, Lee. Use the scale in 311 above to write down the scale drawing of the dimensions of the chair. So they want us to take the scale and use it to actually get a drawing dimension, not the real world dimension, a drawing dimension. So we're going to go to the chair and change all these dimensions to drawing centimeter dimensions, as if you had to measure the chair with a ruler. Okay, So who can tell me what are we going to do to all of these three numbers here? What are we going to do? Our scale is 1:20. What are we going to do, ladies and gentlemen? You tell me. All right, Janie's got an idea that she must divide. She's saying divide by 8. All right, so if we look at our scale, the 20 is from the real world. And if I go from the real world back to the ruler measurements, I'm going to go to 1. Okay, so if I look at the first one, which is 44, how many centimeters should that be? How many 20s are there in 44? Because each 20 centimeters in the real world represents 1 centimeter on my ruler. So how many 20 centimeters in the real world measurement of 44 do I have? So what calculation will I do there? Each 20 centimeters gives me 1 ruler centimeter. So what calculation will I do there, Janu? We need to divide. We need to cut this 44 up into 20s. How many 20s do we have? Okay. So what we're going to do for the first one is we'll say 44 divided by 20. All right. So 44 divided by 20 gives us 2,2. All right. So 2,2 centimeters on my ruler represents 44 centimeters in the real world, which makes sense because 1 on my ruler represents 20. So 2 is about 40, isn't it? So 44 divided by 20 gives me 2,2. Okay. So now the second one, we're going to do the same thing. So it's 105. Excuse me, 105 divided by 20. Let's just change this 44 to 105. And we're going to get 5,25. And we do the same for this one. I'm just going to write you divided by 20, and it'll give me 2,2 centimeters. All right, so we've changed all our real world measurements that are shown in this diagram to scale drawing ruler measurements. So we used our ratio. We went from the right to the left. Usually we go the other way around. Usually we take a ruler measurement and then give us the real world. But they're saying, no, these are the real world measurements. What is it on the drawing? If you had to actually check on the drawing, how many centimeters on the drawing? So we're going the other way. Okay. So we're going to divide by 20.